Good morning, students. Hope you are doing great. This is Dr. Thulasi, working as Associate Professor in the Department of Computer Science and Engineering, Vignan's Nirula Institute of Technology and Sciences for Women, Palakaluru. In the last session, we have seen the third unit. The contents of the third unit are Introduction to UML, Why we model, Conceptual model of the UML. In the conceptual model of the UML, we have seen the building blocks of the UML, rules of the UML, common mechanisms of the UML. And next we have seen the architecture. In the architecture, we have seen the 5 views of the UML. Next we have seen the classes, relationships, common mechanisms, class diagrams and object diagrams. These are the topics which we have covered in the third unit. And in today's session, we are going to discuss about the fourth unit. Coming to the contents of the fourth unit. Today we are going to study about the basic behavioral modeling. And this we are going to discuss about interactions, interaction diagrams, use cases, use case diagrams and activity diagrams. Coming to this session, let's start the basics of the session as usual. And let me start with a question. What is interaction? In every interesting system, objects don't just sit idle. They interact with one another by passing some message in order to achieve some purpose or some behavior. An interaction is a behavior that comprises a set of messages exchanged among a set of objects within a context to accomplish a purpose or behavior. A message is a specification of communication between the objects that conveys information with the expectation the activity will follow. And basically, interaction is nothing but a set of messages, and a message is a information or a communication between the objects by passing some events, operations, etc. to do some activity. You use interactions to model the dynamic aspect of collaborations, representing societies of objects playing specific roles. These roles represent prototypical instances of classes, interfaces, components, nodes and use cases, all working together to carry out some behavior that is bigger than the sum of the elements. The dynamic aspects are visualized, specified, constructed and documented as flows of control that they encompass simple sequential threads through a system as well as more complex follows that involve branching, looping, recursion and concurrency. You can model each interaction in 2 ways. So basically, interactions exist in 2 forms also. They are sequence diagram and collaboration diagram. So by emphasizing its time ordering of messages, this can be done by sequence diagram. Or by emphasizing its sequencing of messages in the context of some structural organization of objects. This can be done by using collaboration diagram. Well-structured interactions are like a well-structured algorithms that are efficient, simple, adaptable and understandable. In the UML, you model the static aspects of a system by using class diagrams, object diagrams, component diagrams and deployment diagrams. Whereas class diagrams, object diagrams let you visualize, specify, construct and document the things that live in your system, including classes, interfaces, components, nodes and use cases and their instances together with the way those things sit in relationship to one another. In the UML, you model the dynamic aspects of the system by using interactions. As I told you that UML consists of 9 types of diagrams and that 4 are static diagrams and 5 are the dynamic diagrams. Coming to the static diagrams, we have seen the class diagram, object diagram, component diagram, deployment diagram. Coming to the dynamic aspects of the system, dynamic models. The dynamic models of the UML are interactions. In the interaction, we are having sequence diagram, collaboration diagram, use case diagram, activity diagram and a state chart diagram. These are the 9 diagrams. 4 diagrams show the static behavior and 5 diagrams show the dynamic behavior of the system. Like an object diagram, an interaction statistically sets the stages for its behavior by introducing all the objects that work together to carry out some action. Going beyond objects diagram, however, interactions also introduce messages that are dispatched from object to object. Most often, messages involve the invocation of operation or sending of a signal. Messages may also encompass the creation and destruction of other objects. So here we use different types of messages like a synchronous message, asynchronous message, found message, lost message, creation, destruction, all we see here. And using interaction diagrams, you can reason about these flows in two ways. First, you can focus on how messages are dispatched across time. This can be done by using the sequence diagram. Second, you can focus on the structural relationships among the objects in an interaction. And this can be done by using a collaboration diagram, which is also known as a communication diagram. The UML provides a graphical representation of messages. This notation permits you to visualize a message in a way that lets you emphasize its important parts, its name, parameter, and a sequence. So see here, every message will be divided into three parts. First one contains the name, and second contains the parameter, and third contains the sequence. So it is not mandatory to have the parameters all the time. If the message required to pass the parameters, then you can pass the parameters. And sometimes every message will have a reply message, okay, to the sender, but it is not always mandatory. Whenever the reply contains the return value, then it is mandatory to send a reply message. Graphically, a message is rendered as a directed line and almost always includes the name of its operations. If you see the figure here, it consists of two objects, a traffic planner and flight plan. In this, it is having two instances, T and P. T for the air traffic planner and P for the flight plan. So here, air traffic controller gets the position of the flight by using the get position at time T. So based on this air traffic planner will get the position of the plane by some communication. So here, this is nothing but a synchronous communication. So what is meant by synchronous communication, we'll see in the later part of the unit. And the flight again getting its last checkpoint. So that is a self message sent to the flight plane. So in this, what you need to consider means we are having some rules. T and P plays the rules, and there is a link between the air traffic planner and the flight plane. And we are having some messages, and messages containing some sequence number, message name, and the parameters which we are passing. That is important to know from this figure. So next, coming to the context. In which scenarios we can use this interactions. So you may find an interaction whenever objects are linked to one another. You will find interactions in the collaboration of objects that exist in the context of your system or subsystem. You will also find interactions in the context of an operation. Finally, you will find interactions in the context of a class. So an interaction may also be found in the representation of a component, node, or use case, each of which is really a kind of UML classifier. Okay, here UML classifier. Why have specifying here UML classifier means? UML classifier we have just studied it while studying the relationships. In the relationships, there are four types of relationships. One is dependency, association, realization, and generalization. These are the four types of the relationships. Coming to the dependency is nothing but a using type of relationship. And association is a structural type of relationship. And generalization is a kind of relationship where if you want to represent the relationship between the parents and the child classes, then you can go for the generalization. So we have never seen where the realization is used. Realization is used when if there are two classifiers. One classifier tries to specify the operations and the other classifier tries to carry out the operations specified in the first classifier. Then we go for the realization relationships. This is regarding the relationships. And next, coming to the one more point of in the which context we are using this interactions. In the context of use case, an interaction represents a scenario that in turn represents one thread through the action of the use case. If you want to tell about the scenarios, then you can go for the interaction diagram. Next, coming to the objects and the roles. Already we have discussed about the objects and the roles. Objects is nothing but it's an instance of class, and a role is nothing but the mask used by the object. So here also we discuss the same thing. Coming to the objects. The object that participate in an interaction are either concrete things or the prototypical things. There are two types of the objects. First one is a concrete thing and second one is a prototypical things. As a concrete thing, an object represents something in the real world. For example, in the above example, we have seen P. P is nothing but an instance. So if we consider another example as a person, if you take a person also, P will be the instancer to represent that person. That is nothing but the concrete thing. If you want to tell about the real world entity, which denotes a particularly human, then we go for the concrete things. Alternatively, as a prototypical thing, P may represent any instance of a person. If you want to tell about the instance, then you can go for the prototypical things. Prototypical itself indicates that is some design, okay, which is not a real thing, which is a design. If you want to represent such things, then you can go for the prototypical thing. Coming to the one of the important things which you need to remember in the interactions is, in a collaboration, the interactors are usually prototypical things that play particular roles, not specific objects in the real world, although it is sometimes useful to describe collaborations among particular objects. An interaction goes further by introducing a dynamic sequence of messages that may pass along the links that connect these objects. Coming to the links and connectors, we always know that a link is a semantic connection among the objects, but if you want to tell about that type of connection in the classes, we go for the association. And in general, a link is an instance of an association. So object is an instance of a class and link is an instance of an association. So while using objects, we go for the links. Connector. Coming to the connector. Connector is a feature which specifies a link that enables communication between two or more instances playing some roles within a structural classifier. A prototypical object is called a role. A prototypical link is called a connector. If you want to tell about the instances, then you can go for the connector. The context is a collaboration or the internal structure of a classifier. Here, if you see the figure, so whenever a class has an association to another class, there may be a link between the instances of these two classes. Whenever there is a link between two objects, one object can send message to the other objects. See here, if you want to represent the association between classes, then you go for the association. If you want to represent the same thing while using the objects, then you go for the links. If you want to represent if both the things are prototypical, then go for the connector. This is a brief introduction why we go for the links, connectors and associations. So next, a link specifies a path along which one object can dispatch a message to another object. So the multiplicity of roles and connectors are defined relative to their enclosing context. So based on this, you can specify the multiplicity and the connectors. So for example, a multiplicity of 1 on a role means one object represents the role for each object. That represents the context. As we know that multiplicity means how many objects are participating in that particular relation. So that is nothing but multiplicity. We have already discussed this. So here I am also telling about the same thing. If you tell that there is multiplicity of 1, then only single object is participating in that particular association. The figure shows a class diagram that declares classes, person and company, and the many-to-many employee-employer associations between them. If you consider the person and company, if you see the figure there, so there will be a person and company. It is having the relationship many-to-many. So you need to represent star and star both sides because company is the employer and a person is the employee. And the second figure shows here the contents of a collaboration, work assignment that assigns an employee to a job. So it has two roles, a connector between them. So if you want to tell about the prototypical instances, then you go for the connectors. And coming to the third figure, so it shows an instance of this collaboration in which there are objects and links bound to the roles and connectors. So this is how we use the associations, links and the connectors. A concrete message in the bottom represents the prototypical message declaration in the collaboration. Most of the time, it is sufficient to specify that such a path exists. If you need to be more precise about how the path exists, you can add on the appropriate end of link with one of the following constraints. So, if you want to specify what that link means, you can specify by using the stereotypes. Here we are having some of the constraints that you can represent on the link by using a stereotype. We already seen that stereotypes can be represented by using the Guillemot symbol, which is nothing but a French quotations. So here we are having 5 types of constraints. First one is the association. Specifies that the corresponding object is visible by association. Next one is self. Specifies that the corresponding object is visible because it is dispatcher of its own operation. Next, coming to the global. We know that what is a global. Global means specifies that the corresponding object is visible because it is an enclosing scope. Next, coming to the local. Specifies that the corresponding object is visible because it is in a local scope. Parameter. Specifies that the corresponding object is visible because it is a parameter. It means if you want to use a link between two objects, if one object is local to other object, then you can use a local stereotype above the link. This is how you can specify all this association, local, global, self and parameter. An important thing we need to know is an instance of an association, a link. Okay, so here a link place which is an instance of association may be rendered with the most of the adornments appropriate to the associations. So it is just an instance of association. So whatever the adornments can be used by the association, that same adornments can be used by the links also. So such as name of the link, association, role name, navigation and aggregation. So one important point which we need to consider is we cannot use a multiplicity while specifying the links. Multiplicity, however, does not apply to links since they are instances of an association. In most models, we are most interested in prototypical objects and links within some context rather than individual objects and links. Coming to the next one, messages. Suppose you have a set of objects and a set of links that connect to those objects. If that's all you have, then you have a completely static model that can be represented by a object diagram. So object diagrams model the state of the society of the objects that at a given moment in a time and are useful when you want to visualize, specify, construct and document a static object structure. Suppose you want to model the changing state of a society of objects over a period of time. Think of it as taking a motion picture of a set of objects, each frame representing a successive moment in a time. If these objects are not totally idle, you will see objects passing messages to other objects, sending events and invoking operations also. In addition, at each frame, you can explicitly visualize the current state and role of individual instances. A message is the specification of a communication among objects that conveys information with the expectation that activity will ensure. The receipt of a message instance may be considered an occurrence of an event, an occurrence in the UML name of an instance of an event. When you pass a message, an action usually results on its receipt. An action may result in the change in a state of the target object and the objects accessible from it. In UML, you can model several kinds of messages. So you can use a call. So it means if you pass a message between the two objects, you can represent a call. So call is nothing but it is also a message. It invokes an operation on an object may send a message to itself, resulting in the local invocation of an operation. If you want to invoke some operation, you can specify the call and you can call the particular operation so that it will invoke the particular operation. So you can also specify as a message as a return. It means if you want to return a value to the caller, then you can specify as a return. And you can also specify the message as sent. It means it sends a single signal to an object. Next, you can also specify the message as a create. Creates an object. If you want to create an object, then you can use this create. So next one is destroy. Destroys an object. An object may commit suicide by destroying itself. These are the different types of the messages you can pass between the objects. So if you see the figure here, it is having three objects. First one is the client, and second one is the ticket agent, and third one is the planning agent. So the client wants to plan some tour. So he'll ask the planning assistant to tell about the tour plan. Then this client automatically it creates a ticket agent. So ticket agent by calculating the route cost, and they will produce an itinerary. So based on this, the client will get the details about the tour plan, and so that he'll destroy the ticket agent and he'll pass the same information to the planning assistant. So this is how you can pass the information between the objects. So it tells about, it gives a clear picture about the interaction among the objects. And here we have used destroy as a stereotype. Destroy message is passed, the object automatically ticket agent is destroyed. So client want to create a ticket agent. So it passed a message create. So the ticket agent is created and it has calculated the value, and the value is taken by the client. And after completion of the task, the ticket agent is destroyed. Okay, this is how the messages are passed. So when an object calls an operation or sends a signal to another object, you can provide actual parameters to the message. Similarly, when an object returns control to another object, you can model the return value as well. Messages can also correspond to sending the signals. So see here, you can send the actual parameters, you can return the values. In the message, you can send the signals also. This is the different uses of using messages. A signal is an object value communicated to a target object asynchronously. Asynchronously means, so if there is no mutual understanding between the sender and the receiver, then that communication, that is nothing but a asynchronous communication. Sender send the message, but receiver, it won't think about the receiver whether he is receiving the message or not. So he just goes for the another message. This is nothing but asynchronous messages. After sending a signal, the sending object continues its own execution. When the target object receives the signal message, it independently decides what to do about it. In an asynchronous message passing system, communicating objects execute concurrently and independently. So if they want to send some message, they'll send, that's it. They won't, that will be done independently. So they share values only by passing messages. So there is no danger of conflict over shared memory. And next coming to the sequencing. So the interaction, in the interaction itself, we are having two types of diagrams. First one is a sequence diagram, second one is a communication or collaboration diagram. So the name sequence indicates sequence. What is this sequence? Sequencing. When an object passes a message to another object, in effect delegating some action to the receiver. The receiving object might in turn send a message to another object, which might send a message to a different object, and so on. So if there is an interaction between the object or among the objects, so you want to know which message is passed first. So you want to give a ordering to the message, that is nothing but a sequencing. The stream of message from a sequence. Any sequence must have a beginning. The start of every sequence is rooted in some process or thread. Furthermore, any sequence will continue as long as the process or thread that owns it lives. Okay. A non-stop system such as you might find in real-time device control will continue to execute as long as the node it runs on it is up. Each process and thread within a system defines a distinct flow of control, and within each flow, messages are ordered in sequence by time. To better visualize the sequence of a message, you can explicitly model the order of the message relative to the start of the sequence by prefixing the message with a sequence number set apart by a colon separator. So, if you see the communication diagram, here you can see a message A message is having a sequence number, that is the message and the sequence is separated by using a colon. A communication diagram shows a message flow between roles within a collaboration. Message flow along the connections of the collaboration is shown in the figure. See here we are having three objects. First one is the view and second one is the controller and cache. So here the view means by seeing a particular point. So it tells a controller click at the point P. So controller automatically it will find the point P and will click at that point P. And the recent value of the P will be picked and it will be stored in the cache memory. This is our figure represents. So here we are having so if there are instances, then we are using the link that is connector. So here we are passing the messages like a click at and put recent page. These are some of the messages passed between the objects. So message is divided into three parts. We know that first one is the sequence number, second one is the message, and third one is the parameter. If there are any parameters, you can pass them in the message. So the sequence number is 2, and we are having some more. If you want to represent the nested loop, then you can go for the 2.1 and 2.2. These are some of the subsequences. If you want to represent the subsequences in the textbook, also you will go for the chapter 1. In that there are some subtopics and you can represent as 1.1. If there are any more subtopics in 1.1 also, you will go for the 1.1.1. So this is how we can represent the message also by using this sequence number. This is nothing but the DY method, and this procedure is known as a procedural sequence. Okay, this is just like a synchronous sequence. Okay, most commonly you can specify a procedural or nested flow of control rendered using the filled solid arrowhead, which is known as a synchronous linking. Okay, if you want to show the synchronous link, that is a solid arrowhead that indicates the message passed between the objects is synchronous. In the case the message find it is specified as the first message nested in the second message of the sequence. So it is represented as a 2.1. And next, if there are any further messages, you can specify them as 2.2. Less common but also possible. You can specify a flat flow of control. So procedural is nothing but a synchronous. If you want to show the flat flow, then that is nothing but a asynchronous. Rendered using a stick arrowhead by seeing just the arrowheads. If it is a filled arrowhead, then you can call it as a synchronous. If it is a open or if it is a stick arrowhead, then you can call it as a asynchronous, which is used to model the non-procedural progression of control from step to step. In this case, the message accept call. So if you see the figure here, we are having three objects: caller, telephone, and exchange. If you see the figure here, and it is having a flat sequence, there is no subsequences. So just we are having, if it is a flat sequence, we can give as 1, 2, 3, so on. If there are subsequences, means if you want to represent the procedural or nested sequence, then you go for the 2.1, 2.2 subsequences. So in the flat sequence, we are having three objects: caller, telephone, and exchange. So in the first message, so if you want to make a call to the someone, if you want to make a call to your friend, then what you will do? You will pick the phone, you will pick the receiver, you will lift the receiver, and you will hear a voice. Okay, you will hear a notification of ringing notification. If you hear dialing tone, that is nothing but a dialing tone. If you hear that, then the phone is in working state. If you can't hear anything, then the phone is in a dead condition. You can't make any calls. That is the reply message you are getting. So after you getting the dial tone, you can dial the numbers, so that numbers will be connected in the exchange to the client which you want to call. So that is here we are discussing about that things that is represented here by using the three objects, and we are having some messages like one lift handler and the second is a accept call. These are the two messages which are having some messages and sequence numbers also. So here if you see the arrowhead, that is a strict arrowhead or open arrowhead, which indicates the asynchronous communication. Okay, this is regarding the different types of communication which we are discussing, and later part we will discuss more about this asynchronous and synchronous communication also. And one important point here you need to note is The distinction between asynchronous and procedural sequences is important in the modern concurrent computing world. To show the overall behavior of a system of a concurrent objects, use a asynchronous message passing. This is the most general cases. When the calling object is able to make a request and wait for their response, you can use a procedural. So see here, if you want to use the asynchronous means if you don't want any response from the receiver, then you can just go for the asynchronous. If you want a response, which is very important, if you feel receiving a response is important, then you go for the synchronous or a procedural flow of a control. So if you have more time to wait for the response, then you can go for this synchronous. And procedural flow of control is similar form of traditional programming languages. But keep in mind that a series of nested procedure calls result in a stack of blocked objects that are temporarily unable to do anything. So it is not very useful if they represent servers or shared resources. When you are modeling interactions that involve multiple flows of control, it's especially important to identify the process or thread that send a particular message. In the UML, you can distinguish one flow of control from another by prefixing a message sequence number with the name of the process or thread that sits at the root of the sequence. So here I want to tell one of the example. So if you have an expression d5 colon eject hash 3. So if you see this expression, what does this expression means? Means d5. It specifies the operation. Here we are having one operation eject hash. That is the operation. So how we can consider this as operation means we are having in the operation we specify by using the parenthesis. So this eject hatch is dispatched and it is having a argument 3, that is the actual argument 3, and the message is the fifth message in the sequence d1, d2, d3, d4, d5, and d5 indicates the fifth message in the sequence routed by the process or the thread name is d. This is how you need to identify the message and you need to know the sequence of the messages. And one important point you need to note here is in the UML you can also model more complex forms of sequencing such as iterations, branching and guard messages. Yes, really in programming language you can do this iterations, branching, guarded messages by using if else, switching, for loops and conditions. You can specify this. But how this can be done in modeling language? We can also do the same thing in the modeling language also. And you can represent the iterations, you can tell about the branchings, and you can also tell the guarded message in the modeling language also. So let's see how we can do that in the modeling also. In addition to model timing constraints, such as you might find in real-time systems, you can associate timing marks with a sequence. Other more acoustic forms of messaging are bulking and timeout. Can be modeled by defining an appropriate message stereotype. If you want to destroy a message, if the time is out, you can specify by using a stereotype. You can specify them on the message name, telling that you need to, time is out. You can specify by using a stereotype. You can represent any type of messages, okay, by using the stereotypes. Next, coming to the creation, modification and destruction of message. How you can do the creation, how you can modify the message, how you can destruct the object. So creation is nothing but if you want to create some object, then you can give a message create. Most of the time, the objects you show participating in an interaction exist for the entire duration of the interaction. However, in some interactions, objects may be created. So if you consider an example, I want to compose a mail. So in this example, what I need to do means, I need to have a system. So I need to compose a mail. To have a composition of the mail, I need to connect it to one of the servers. Either it might be Gmail server, Yahoo server, Reddit mail, whatever might be. I need to connect to some server. So before using that server, I need to register for the server. I need to have the login credentials. So after having the login credentials, I can give my user ID and password to the server. So server automatically creates the authentication server by sending a message create. So this authentication server, what it does is, it takes the user ID and password, it tallies with the database user ID and passwords, It tells whether the user is valid or not. So if the user is valid, then it passes the message to the Gmail server. He is a valid user. You can enter him. Or else it tells a message, he is not a valid user. Automatically Gmail server will give a response like check your user ID or password. So based on this, what you will do means, if you are the valid user and now the object authentication server purpose is over. So again you no need to validate yourself. So automatically Gmail server, what it will do means, it destroys the authentication server. Okay, this is how you can create whatever the objects you want required in that particular scenario, or else you can destroy the objects by sending a create or destroy message. Okay, the same is true of links. The relationships among objects may come and go. To specify if the object or link enters and or leaves during an interaction, you can attach a note to its role within a communication diagram. So if any object comes and goes, you can write a note. The note is used to specify the commands. When the object is came, why does the object come? That can be represented by using the note. During an interaction, an object typically changes the values of its attributes. Its states or its roles. You can represent the modification of an object in a sequence diagram by showing the state or the values of the lifeline. Within a sequence diagram, the lifetime creation and destruction of objects or the roles are explicitly shown by the vertical extent of their timelines. It means if you create any object in the sequence diagram, so that object creation is indicated by the head of the object. Okay. Down of that head of the object, you will be having some dotted line that indicates the lifeline of that particular object. Within a communication diagram, creation and destruction must be indicated using the nodes. Okay, so in the sequence diagram, you will represent the life of the object or scope of the object by using this lifeline. If the lifeline is ended with a cross symbol, it means the object is not in that particular scenario. It means the lifespan of the object is completed in that particular scenario. So if you want to tell that in the communication diagram, you can represent that by using the nodes. Use sequence diagram if the object lifetime are important to show. If you want to show how much time the object is alive in that particular scenario. So after what communication the object is destroyed. So if you want to know that, if you want to represent everything in a orderly manner, then you go for the sequence diagram. So in the collaboration diagram, you can't represent all the lifelines. So in the collaboration, it always tells about the structural organization of the objects. It can't tell about the lifelines. So if you want to represent the lifelines, then better you go for the sequence diagram. Coming to the representation. When you model an interaction, you typically include both roles, each one representing objects that appear in an instance of an interaction. That is nothing but the role. And the message, each one representing the communication between the objects with some resulting action. You can visualize those roles and messages involved in an interaction in two ways. By emphasizing the time ordering of the message, this can be done by using the sequence diagram, and by emphasizing the structural organization of the roles and that send and receive message, this can be done by using the collaboration diagram or communication diagram. In the UML, the first kind of representation is called a sequence diagram. The second kind of representation is called a communication or collaboration diagram. Sequence diagrams and communication diagrams are similar and are isomorphic, meaning that you can take one figure and transform it into the another figure or diagram. Although they often show different information, so it may not be so useful to go back and forth. Okay, the representations of interactions are two forms, that is sequence and collaboration. There are some visual differences. First, the sequence diagram permits you to model the lifeline of a system. So lifeline means, as I told you, that it is nothing but a dotted line below the head of the object. So an object's lifeline represents the existence of the object at a particular time, whether the object is existence in that particular scenario or not. That can be represented by using the lifeline, possibly covering the object's creation and destruction. If the destruction is done by using the destroy message, you need to represent the lifeline. At the end of the lifeline, you need to represent by a cross symbol. That indicates that object is no more going to take place in this particular scenario. Second, Communication diagram permit you to model the structural links that may exist among the objects in an interaction. Coming to the common modeling techniques of interaction. So first one is to model the flow of control. Only one is there, that is the how to model the flow of control. The most common purpose for which you will use interactions is to model the flow of control that characterize the behavior of a system as a whole, including use cases, patterns, mechanisms, and frameworks, or the behavior of a class or an individual operation. Whereas classes, interfaces, components, nodes, and their relationships model the static aspects of your system. Interactions model its dynamic aspects. When you model an interaction, you especially build a storyboard of the actions that takes place among the set of objects. It means while going for a movie, so you'll have an illusion that the movie is continuous, but they are taken in a static frames. They are combined and they are played 24 frames per minute or per second. So that makes you a continuous image. Similarly, here also we'll have a interactions. So based on these interactions, if we combine all those interactions, that gives a continuous motion picture. Techniques such as CRC cards are particularly useful in helping you to discover and think about such interactions. So coming to the how to model a flow of control, what are the steps? First of all, you need to set the context. That means context is nothing but the scenario for this interaction. Whether it is a system as a whole or a class or an individual operation. Next point is set the stage for the interaction by identifying which objects play a role. Set their initial properties, include their attribute values, state and role. So you need to identify the objects, you need to tell the initial properties of those objects. Next point is, if your model emphasizes the structural organization of these objects, identify the links that connect them, relevant to the paths of communication that take place in the interaction. Specify the nature of the links using the UML standard stereotypes and constraints. We also seen the standard stereotypes. Okay, we have seen the association, we have seen the local, global, self. Okay, these are some of the messages. You can use those stereotypes. Okay, next, in a time order, specify the messages that pass from object to object. As necessary, distinguish the different kinds of messages. Include parameters and return values to convey the necessary detail of this interaction. Also, to convey the necessary details of this interaction, add on each object at every moment in time with its state and role. For example, if you see the figure here, it consists of set of roles that interact in the context of publish and subscribe mechanisms. Okay, if you see the figure, it is having three objects: stock code publisher, stock code subscriber, stock code subscriber. So this coming to this example, I want to give one more example before telling this example. So if you consider my YouTube channel, I am the publisher of my channel because I can add videos, I can remove the videos. So I am the publisher of my YouTube channel. And I ask you people to subscribe my channel. If you subscribe my channel, what will happen? So whenever I add new updates, whenever I add new videos to my channel, the same updations will be received by all the subscribers. So that's what here we are explaining here. Now this also same here. There is a stock code publisher and there are some subscribers. Whenever they are attached to the publisher, whenever he passes some information, that will be updated to the same subscribers also. That is the same example explained here. See there are three objects and having instances publisher for P and subscriber 1 S1 and subscriber 2 S2. First of all, subscriber is attached to the publisher. Next, second subscriber is also attached to the publisher. So the same information is notified. Whenever you subscribe my channel, then I'll get the notification of this so and so subscriber added to your channel or subscribe to your channel. That information is given to me. Similarly here also will get a notification. Next, If I have uploaded a video, then that uploading or that information will be updated to all the subscribers. Same information will be updated and I'll get the status also. Okay, this is known as this example is updated here. This tells about the flow of control by time, how the information is passed, how the interaction is done by in a timely manner. So the collaboration diagram, for the same sequence diagram will have a collaboration or a communication diagram. So the collaboration diagram is semantically equivalent to the previous one, but it is drawn as a communication diagram which emphasizes the structural organization of the objects. This figure shows the same flow of control, but it also provides a visualization of links among these objects. So if you see the communication diagram here also, here it is having 3 objects, and whatever the communication done in the sequence diagram, same communication is shown here, but with a sequence number. So there is no timeline, there is no order is showing in this, so we have given some sequence number so that we can easily understand that which message is passed first and which message is passed second. So this is what explained here. So both the sequence diagram and the collaboration diagram are isomorphic or semantically equivalent diagrams. So this is regarding the interactions. Coming to the few tips and hints I want to share with you. When you model interactions in the UML, remember that every interaction represents a dynamic aspect of the society of the objects. A well-structured interaction is simple and should encompass only the objects that work together to carry out some behavior bigger than the sum of all the elements. Has a clear context and may represent the interaction of objects in the context of the operation, class, or the system as a whole. And what are the interaction diagram you draw? That should be efficient and should carry out the behavior with the optimal balance of the time and resources. And whatever the interaction diagram you draw, it should be adaptable. The elements of an interaction that are likely to change should be isolated and so that they can be easily modified. So it should be very understandable and should be straightforward, involving no hacks, hidden side effects, and these are the things you need to follow while drawing an interaction diagram. So this is regarding the interactions. Next, coming to recap. Let's have a quick recap about the topics which we have discussed so far. In this unit 4, we have discussed about the basic behavioral diagrams, in which we have discussed about the interactions. In the interactions, we have seen about what is an interaction, what are the messages and the links, and how to use the stereotypes while using the links. And we have seen about the sequence diagram. In the sequence diagram, we have discussed about the lifeline and focus of the control. Coming to the collaboration diagram, we have discussed about the links and the sequence number. We came to know that sequence diagram and collaboration diagram are semantically equivalent and isomorphic. And we have seen the common modeling techniques of interactions. In the interactions, we have seen only one common modeling technique, that is to model the flow of control. Next, coming to the interaction diagrams. In the interaction diagrams, we have gone in detail about the sequence diagrams and the collaboration diagrams. Both are semantically equivalent and both are isomorphic, but they are not representing the same information. Okay, coming to the common modeling techniques of interaction diagrams, we have seen 2 common modeling techniques. To model the flow of control by time ordering, and second one is to model the flow of control by organization. So these are the 2 common modeling techniques we have discussed in the interaction diagrams. Next, we have seen about the use cases. And we came to know that use case is used to represent the scenarios or set of these sequences. And next, in the coming to the common modeling techniques of the use cases, these are used to represent the behavior of the elements. And next, we have seen about the use case diagrams. In the use case diagrams, we have discussed about the relationships such as generalization, extend, and include. And coming to the common modeling techniques of use case diagrams, we have discussed about the modeling the requirements of a system, and next is modeling the context of a system. And coming to the last interaction diagram which we have discussed in this basic behavioral modeling is activity diagram. So here we have seen about what is an activity, what are the activity states, and we have seen about the swim lanes, and these are the different topics which are new to us. We have discussed all these things. And coming to the common modeling techniques of activity diagrams, we have discussed about how to model the time constraint and how to model the distribution of objects. That's what we have seen in this basic behavioral modeling. And this is regarding a quick recap regarding the unit 4. Next, coming to the important topic, that is interesting one also, that is quiz. And by seeing this quiz questions, you will understand how you are clear about the topics. So let me start the quiz. First question. Dash are used to model the dynamic aspects of collaboration. Coming to the options, sequence diagram, structural, interactions, D messages. So the answer is interactions. Coming to the second question, interaction diagrams are of dash types. So options are 1, 2, 3 and 4. So interaction diagrams exist in two forms. One is a sequence diagram, second one is a collaboration. Dash diagrams permit you to model the lifetime of an object. So if you want to tell about the lifetime of an object, which diagram is used? So sequence diagram, collaboration, state chart, activity. So we know that lifetime can be represented by using the lifeline of an object. That can be represented in the sequence diagram. And dash shows an interaction consists of a set of objects and their relationships, including messages. So options are interaction, class, use case, activity. So it is telling about the interaction, objects and their relationships, that is none other than interaction diagrams. Next question. The behavior of a system is modeled using class diagram, activity diagram, use case diagram, interaction diagram. This can be done by using the use case diagram. That's what we have seen in the while telling about the architecture of the UML also. We have seen about the 5 views. In that, one of the view is use case view. In that, it tells about the behavior of the system. In an activity diagram, organizing the activities into groups is called options: forking, joining, swim lanes, synchronization. Option C, swim lane. Dash is used to represent concurrent flows in an activity diagram. The options are slide bar, synchronization bar, swim lane, branch. The answer is synchronization bar. Coming to the next question. Executable atomic computations are called A. Action states, activity states, composite states, concurrent states. The answer is action states. Activity diagram is a special kind of dash. Use case diagram, state chart diagram, interaction diagram, component diagram. The answer is state chart diagram. Which of the following diagram view the whole system as a block box? So, class diagram, activity diagram, use case diagram, interaction diagram. So, block box, that is nothing but use case diagram. Actors are connected to the use cases only by association relationship, generalization, realization, dependency. We have already discussed this, that is association. Forward engineering is the process of translating dash. Options: model to model, code to model, model to code, code to code. That is model to code. Dash relationship between use cases means the base use case explicitly incorporates the behavior of another use case at a location specified in the base. The options are exclude, extend, include, abstract. The answer is include. So these are the few questions which we have covered in the basic behavioral modeling. And if you can answer these questions, you understood the class well. If you have any doubts, go back and play the video. Okay, if you think that I am going a little bit fast, then play the video slowly. Hope you people know about it. If you don't have any idea, just go to the settings symbol on the video, click on playback speed, then customize the speed according to your need. Thank you so much. Let's meet in the next session with the Unit 5. Till then, have a safe day. Follow SMS. SMS means sanitizers, masks and social distancing. Stay safe, stay healthy. Thank you.